Imagine uploading an invoice and having AI automatically extract every detail like vendor names, amount, date, line items, and then intelligently classify it into the right expense category, all in under 10 seconds. No manual data entry, no human error, just pure automation. I built exactly that, and I am going to show you how it works. I built a complete AI-powered invoice automation system using Azure Cloud Services. This is a full-stack serverless application that combines computer vision for document extraction with large language models for intelligent classification. We will do a live demo of the application, and then I'll walk you through the key code that makes it all work. Let's dive in. Here is the application running. I have the Next.js frontend running locally on localhost, and it's connected to Azure Functions backend that's already deployed in the cloud. So everything you are about to see, the document extraction, AI classification, database storage, all of that is happening live on Azure services. Let me show you how it works. Here is the main upload page. I'll drag and drop a sample invoice and watch what happens. The application is now processing the invoice. It uploads it to Azure Blob Storage, then calls Azure Form Recognizer to extract all the structured data, and finally uses an AI language model to classify it into a business expense category. And there we go. Processing took just a few seconds. Let's see what it extracted. Vendor name, invoice number, invoice date, total amount in the correct currency, uploaded date, and the processing time. Here you can see the AI classification. It correctly identified this as IT service and software with a 95% confidence score. And it even provides the reasoning for why it chose that category. Below that, you can see the line items extracted from the invoice. All this data is saved in the Cosmos DB database in Azure. Now let's go and navigate to the dashboard. From the navigation bar, here the app loads all processed invoices from the database. You can see some information like how many invoices are already processed, the total amount of them, the average processing time, and the number of categories. You can also see the category breakdown and the list of all invoices. Let me click on one to see the full details. Perfect. This invoice detail page shows everything we extracted. Plus, you can view the original document right here in the interface. Now that you have seen it in action, let's look behind the scene to understand how it actually works. Here is our code repository inside VS Code. Let's start with the backend. Here is the main upload function inside the upload invoice.cs. This is an Azure function with an HTTP trigger that handles post requests. First, it extracts the file from the multi-part form data, then it validates the file type. We only accept PDF and images. We then read the file stream into the memory. Next comes the processing pipeline. We have 4 service calls happening. Let's break it down. First, we upload the file to Blob Storage. Then Form Recognizer extracts the data. Next, the AI model classifies it. And finally, we create our structured data from the extracted data and save it to Cosmos DB database and return it to the front end. Let me briefly show you the Form Recognizer service. This is where the magic happens. We create a document analysis client and call analyze document. We are using Azure pre-built invoice model. The beautiful thing is that Form Recognizer is specifically trained on invoices, so it knows exactly where to find vendor names, invoice numbers, dates, line items, and totals. We are just parse the result and map them to our data model. Now let's look at the AI classification service. This is really cool. We are using a large language model to intelligently classify invoices into business expense categories. We craft a prompt that includes the vendor name, amount, and line items. And we ask the model to return JSON with the category, confidence score, and reasoning. The prompt engineering here is key. We provide a list of valid categories and ask it to think like an accountant. The model returns a structured JSON that we deserialize into our classification model. This gives us not just a category, but also confidence and explainability. Now let's look at the frontend code. It's in the frontend folder in our repository. This is all built with Next.js and React. Here is the main upload page at page.tsx. We are using React hooks for state management. The file upload functionality is defined inside the file upload component. Let's look at it. We are using the React drop zone package for drag and drop functionality. When a user drops a file, we validate it client side, then make an API call to our Azure function backend. The really nice part is the loading state and error handling. While processing, we show a spinner. If successful, we display the extracted result in a clean layout. If there is an error, we show a user-friendly message. Let me show you the dashboard that we defined inside dashboard folder page.tsx. This page fetches all invoices from the getInvoice API endpoint. It calls the Azure function in our backend that we defined to get all invoices. We are mapping through the result and rendering static cards and invoice list in a responsive grid. Let's take a look at the invoice list component that we defined here. Each row is clickable and routes to the invoice detail page using Next.js dynamic routing. Now we can take a look at the invoice detail page. It uses ID from the URL params to fetch a specific invoice data and display it along with the embedded PDF viewer. Now that we have explored the code, let's zoom out and see how all the pieces fit together in the overall architecture. The front end is a Next.js app that can be deployed to Azure static web apps. It communicates with the Azure Functions backend through REST APIs. The backend orchestrates everything. Blob Storage stores the original invoice files, form recognizer, extract the structured data using computer vision, the AI language model classifies the invoice intelligently, Cosmos DB stores all the metadata and results. Everything is serverless, which means it auto-scales based on demand and you only pay for what you use. The application supports multiple file format, PDFs, PNGs, JPEGs, multi-page invoices, different invoice layouts, multiple currencies, and it maintains high accuracy, over 95% on standard invoices. Processing time is typically around 4 to 7 seconds per invoice, which is pretty impressive considering all the AI processing happening behind the scene. So that's the Smart Invoice Automation System, a complete serverless AI workflow built on Azure. All the code is available on GitHub. I put the link in the description. If you found this useful, subscribe for more real-world cloud and AI projects. Thanks for watching and happy coding.